Hi again. This is question number 3 from the worksheet I've asked you to try for week 1 on Monday. I'm not going to do the whole thing, but I kind of want to go through some of the thought process that you're going to need for certain problems. So, again, like I mentioned before, let's start with the question. What is it asking you to find? Second sentence, asking for you to find how fast is the top of the ladder sliding down the wall. Okay, so with some of these problems, not all, but with a lot of them, it's helpful to draw a picture. So basically we got a wall, we have the wall goes into the ground, pretend that's a right angle there. You have a ladder leaning up against the wall. Okay, so what we have is, in all these related rate problems, if there is something that is changing, it needs to have a variable. So for this problem, this is the height. You can call it whatever you want. I'm going to call it X. That's the height of the ladder against the wall. We have the distance from the base of the wall to the bottom of the ladder. I'm going to call that Y. Again, call it whatever you want. Those two things are changing, no doubt about it. But with these related rate problems, anything that is staying the same, it doesn't matter, like it says in the notes, it doesn't matter if it's staying the same number or if there's the same relationship. Like I think I said in the notes, like the height of something is always twice the radius. If there is something that is a constant, plug it in before you take a derivative. So the length of the ladder is not changing. It is staying constant. So we're just going to call this 5. Okay. So the equation that we need. The question is, how fast is the top of the ladder sliding down? So what we're asked to find is the change in X with respect to time. Okay, that's what we're trying to figure out. That's a weird looking question mark, but that's okay. So these 3 things, height of the ladder, the distance of the base of the ladder, and the length of the ladder, they're all related with the equation Pythagorean theorem. X squared plus y squared equals 5 squared. Okay, there's our equation. So the question is asking what's the change in X, at least X is what I call this one. You are given some things. The base of the ladder is sliding away at a rate of 1 meter. So that distance of the base of the ladder is y. So we're given the change in y with respect to time. That was 1 meter per second. How fast is the top of the ladder sliding down the wall at the instant when the base is 3 meters from the wall? So the question is telling us that at that instant, y is equal to 3. Now, when you go and take the derivative, remember you're taking the derivative of every term. You are applying a chain rule idea. Every variable is a function in terms of time. So I'm going to start this. Like I said, I'm not going to finish this whole problem, but the derivative of x squared is 2x. Thinking chain rule, derivative of that inside function, the change in x with respect to time, plus change in y squared, or the derivative of y squared, equals the derivative of 5 squared. Okay, so you can finish that off. Something to pay attention to. The question is asking how fast is the top of the ladder sliding down the wall? Top of the ladder is going down. So that means this value of x is actually decreasing. So when we go and find the change in x, if the function is decreasing, that meant that derivative is negative. We haven't talked about that in a while. So that's where I'm going to leave you. You're trying to solve for this. You're going to have to do a little bit of extra work because right here we need to know what x is. We only know y. Think about Pythagorean theorem. Hope that helps you.